SDXL has been out for a couple of weeks now, and the general consensus has been that Comfy UI is the preferred method to work with this model, particularly due to the fact that the base and refiner model have been split apart, not to mention the additional layers of control that Comfy UI gives. A few checkpoint merges have started to be released that combine the base and refiner outputs into a single model that you can use with Automatic 1111. A lot of people have been complaining about how complex Comfy UI is, how scary it can look with the nodes and cables flying all over the place. Essentially, noodle soup. However, that doesn't have to be the case. Comfy UI can be as easy as using Automatic 1111 or as complex as you want it to be. In fact, I've included a link in the description with a configuration file that will more or less replicate Automatic 1111 text-to-image interface as closely as possible. In this series, we aim to go from absolute beginners to Comfy UI pros, having an understanding of what each of the main components do. If this kind of content is interesting to you, please don't forget to like and subscribe. It really helps the channel out. To start, we're actually going to open up Automatic 1111 and go over some of the key elements that we're going to try and replicate in Comfy UI. The key components are the positive and negative prompts, textual inversions, hypernetworks, and LoRa's, the seed, the CFG scale, restore face and A detailer, high res fix, and control net. These are the main components most commonly used in Automatic 1111, and we'll aim to replicate these over the course of the series, as well as explore more advanced settings that you can do with it. Heading over to Comfy UI. By the way, if you haven't gotten it installed or are using a RunPod instance, I have a separate video that explains how to do that. Once we're in Comfy UI, you'll be greeted by a screen that looks something like this. It could be completely empty, or it will have the default nodes already set up. Just so that we're on the same page, go ahead and click the clear button so we can start from an empty page. Now, there's two main ways to create nodes on the canvas. One is by right-clicking, and when you do that, you'll see this little menu pop up, which allows you to go into the different categories and select which node you want. This is great if you're not entirely sure what you're looking for and you want to explore the nodes and what they do. The other way is by double-clicking on the canvas, and you'll get a little search box, and you can very quickly type in the node that you're looking for. This is great because for me, sometimes I forget which category a particular node is, and it's just faster to double-click and go after the node I'm looking for. In this case, we're going to grab the simple checkpoint loader named Checkpoint Loader Simple. We're just going to type it in and grab it and drop it over here. Now, you'll also see here that there is an advanced version of the checkpoint loader. We will not be using it at this time, and that allows you to load in a configuration YAML file. We'll go ahead and delete that. Now, in our load checkpoint node, I'm going to go ahead and click in the window here and select SDXL base 1.0. Now, you'll notice there's three little dots here called model, clip, and vey. These are going to be how we connect our nodes to other nodes, and we'll get into that later on. Now, the next node we're going to grab is one called K-Sampler. And again, there's two variants of this, K-Sampler and K-Sampler Advanced. We're just going to use the standard K-Sampler for now, but we will need to get into the advanced one later on to make the most of SDXL 1.0. Now, the K-Sampler is the component that does the heavy lifting for your model. You'll notice some sections here that look similar to what you might have seen in Automatic 1111. This is where your seed is input, your CFG is input, as well as other parameters that affect the output of your prompt. Next, we need to connect the K-Sampler to the model that we're using. To do this, we connect the two model purple dots together to connect the two nodes. Next, we need to actually connect our positive and negative prompts. We do this by adding on a pair of nodes called clip, text, and code. And what this is this takes your prompt and applies it to the model to get the desired output based on the parameters of the K-Sampler. So in this case, we're going to add two clip, text, and code nodes, one for the positive and one for the negative. And like before, we connect the matching dots on the node. So on the model, clip to clip, and on the right side, conditioning to positive for this one and negative for the other one, as you'll see here. And lastly, you'll notice in the K-sampler there is a dot called latent image. Here we have to connect it to a node called empty latent image. And what this is it is a blank image in a latent format, which is a format that the AI models can understand. In this case, we're submitting an empty one because this will be the starting noise that will be used to generate our image. In this case, we need to set our latent image to 1024 by 1024, as this is an image size that works best with SDXL 1.0. Great. And once that's done, we can now head into the K-sampler and start to understand what each of these lines mean and how they compare to automatic 1111. So as I said before, we have our seed, just like we have in automatic 1111. Now, underneath it, you'll see control after generate. What this does is this allows you to decide whether to keep your seed the same, whether to generate a new random seed, or whether to increment it by 1, just like you can set these things in automatic 1111. Steps, this is just like steps in automatic 1111, where you decide the number of steps and iterations that the model is going to go through to generate the image. CFG determines how much creative freedom you're going to give your model, just like in automatic 1111. Sampler name is deciding your sampler method, just like in A1111. Scheduler, denoise is simply a percentage of the number of steps that you want the K-sampler to complete. So in this case, if we've got 20 steps and we set the denoise to 0.5, it will only complete 10 steps out of the 20 in the denoising process. Essentially what this means is you may end up with a noisier image. Okay, so now we're going to do a little bit of housekeeping and try and lay out the nodes to look something like they do on automatic 1111. So we'll move this here, pop this here. Now, let's finish this flow. You'll notice on the right-hand side of the K-sampler, there's a little dot that says latent. This means that the K-sampler is going to output a latent image. We now need to convert that into a pixelated image that we can view. We use that using a VEI decoder. You may have noticed VEI in automatic 1111 on the top right, where you can select different VEIs to affect how your image output is. That's the same thing. It's a decoder. It translates your latent image into pixels. So we're dropping the VEI decoder here. And like in automatic 1111, we're going to add in the load VEI node, where we can select the SDXL VEI and connect it to the VEI dot. And we're going to connect latent to samples. And finally, we want to be able to output and save our image. In this case, we're going to use the save image node and connect the image dot to the image dot on the save image node. And there we go. With a little more adjusting, we've basically got the skeleton structure of automatic 1111 in Comfy UI. So now we're just going to adjust some of these nodes to clean things up. Okay, so now we can plug in some prompts to try and generate an image. I've already set up a negative and positive prompt here, where I also forgot to connect my negative prompt to the K-sampler, which I'm doing now. If you want to try out this prompt, I've left it in the description below. It took a little bit of experimenting to get an image that I wanted to work with. And once we're ready to see what the output is, we go ahead and click Queue Prompt. And if we want to see how the development of that prompt is going, we can also just click View Queue. You may now notice some of the nodes are starting to turn green. This is at what stage the development of your image is at. So right here, it's at load checkpoint. Then you'll see it go through the clips, the K-sampler, and save image. And there you go. We finally got our image. Now, as you may know, part of working with SDXL is about sending your prompts through the base and then through the refiner model. So we're now going to work on the refiner side. Before we continue, let's group this up so that it's nice and tidy, so that we know which are the nodes that belong to the base side of the equation. Like for the base model, we now need to load the refiner checkpoint, so we'll do this by using the same node. We need to give the refiner its own K-sampler. And of course, we connect the checkpoint to the new K-sampler. Now, the K-sampler also requires its own positive and negative clip. Now, we don't want to have to type out the same prompt for the base and the refiner, so we're just going to connect the existing clips from the base model onto the refiner K-sampler. One of the key differences on the refiner side of this graph is that the latent image the K-sampler takes as an input is no longer going to be a blank latent image. In fact, it's going to be the output of the K-sampler from the base model. In this case, we connect latent to latent image, and we're now feeding into the K-sampler the semi-finished image to continue working on. Like before, we're also going to add the VE model loader and VE decoder. And finally, the save image. Now, this is going to give us an error, which we're going to correct now. And the reason for that is because we are trying to use the same clip in multiple K-samplers. Now, the reason we did it this way is because we want to keep our Comfy UI experience simple and easy to use. And one of the ways that we do that is to not have to keep inputting the same text again and again if we're using it in multiple K-samplers. So the correct way to do this without having to have multiple text boxes to input the same thing again and again is we can actually extract elements from the nodes and reuse them in multiple nodes. So in this case, for the clip, we are going to right-click the clip and convert the text to input. And you'll notice the node goes blank. Don't worry, your information is still saved. You'll notice there's now a new input on the right-hand side called text. We're going to click on that input out into the canvas, and when we try and click anywhere on that connection, you'll see a drop down of nodes come up. We're going to go down into utils and select primitive. You'll now notice that the text that you had before in clip has been filled out here into this primitive one. We're also going to do the same thing for the negative prompt. And now that the clip nodes are empty and so big, we're just going to resize them to clean things up. And we're actually going to duplicate these clips and move them over to the refiner side. And now we can connect the text boxes to the respective clips and then the clips into the refiner K-sampler. So essentially what we've done is we've given each K-sampler their own negative and positive clips, but we are reusing the same text across the clips and K-samplers. And this is why we were getting the error earlier. It does add a little bit of messiness to the way that it's done, but we can always put these nodes out of the way to get the output that we want. And now if we click Q prompt, we will see a new base image and the refiner output, which should, in theory, be an improvement on the base model. In this case though, you'll see we got something kind of similar, but also very different, and in fact quite gruesome. This is definitely not an improvement on the base image, it's still a different image entirely. So why are we getting this problem? Well, as I mentioned earlier, to successfully use the SDXL model, both the base and refiner together, we actually need to use the advanced case sampler nodes. So now we're going to go in and replace the case sampler nodes for their advanced variants and explain the additional components and how they make everything work together. So let's replace the base case sampler for the advanced one and reconnect everything. And we'll do that for the refiner one as well. Great. And now that everything is re-plugged in, what do we need to do differently to make this work? So if we head over to the base advanced case sampler, you'll notice 3 new lines that weren't in the previous case sampler. Start at step, end at step, and return with leftover noise. And basically what this does is allows us to output an unfinished image out of the base model. This is why the return with leftover noise line is so important, because what we're doing is we're allowing the model to output an image with noise left over. And then the refiner model will go in and finish removing the noise, focusing on improving and adding in details rather than what was happening before, where it was trying to regenerate the image as if it had a full layer of noise. So in this case, we're just going to leave it at 20 steps. And if we head over to the refiner case sampler, we can see here that we've got the same lines, but now we're going to change the start at step to 20, which is where the previous one ended. And we're just going to add on an additional 20 steps. So let's finish it up at 40 and keep the number of steps the same. And if we cue the prompt, now you'll see the 2 images look almost identical. In fact, if we zoom in, they are identical. So what's going on here? The refiner doesn't seem to have done anything to refine the base image. Well, this is probably happening because we're giving the base model too many steps and it's outputting a finished image with no noise for the refiner to work on. So if we come back to the base case sampler and we drop down the ending step to 16 and we set the refiner case sampler to start at 16, you'll now see that the output of the base model gives us the outline of an image that's still very noisy, which the refiner model can then take and tweak. And we can see here the refiner model looks absolutely phenomenal. The image looks detailed, there's great lighting, and so on and so forth. Before we finish up, in the spirit of trying to keep things simple and keep our workflow as easy to use as possible, we are just going to extract out of the 2 case samplers, much like we did the positive and negative prompts, the starting and ending step, so that you can just set it once and that will become the ending step for the base case sampler and the starting step for the refiner one. And we're going to do this by right clicking on the case sampler, and for the base one we are going to convert end at step to input, and on the refiner start at step to input. Then, just like before, we're going to create a primitive and then connect that primitive to the new outputs on both. And now we no longer have to keep jumping back and forth between the 2 case samplers every time we want to change the starting and ending steps. And that's basically it. We now have a full working workflow from beginning to end using both the base and refiner model. And don't forget to like and subscribe and click the bell icon to stay updated for new videos. It really helps the channel out. If you want to make use of this workflow, I've included the JSON file below. You can just drag it into your Comfy UI interface and it will work. I recommend you go in and play around with the parameters, adjust the starting and end steps, the number of steps, the CFG, etc., to see what kind of different images you can get. Have some fun with it, and I'll catch you guys in the next one where we will start looking into prompts and integrating embeddings and prompting techniques to try and get better images.